to Three.js online meeting. Three.js online meeting is where people come and talk about interesting things they have done with Three.js. It's gonna last around 1 hour or so, and today we're gonna talk with Ben Houston, leader of Clara.io team. Clara.io is a modeler that you can use inside your browser. It has been done with Three.js, and I think it's very cool. How are you, Ben?
Hi, I'm doing very well, and thanks for the great introduction.
Excellent. So this is our first Three.js online meetings, so I'm a bit nervous, even if we did some in the past, like 2 years ago. So we will see how it goes. So thanks, Ben, for trying it with us, and let's get it immediately started. It's up to you now, Ben.
Okay,
Go ahead.
so I guess I can start with saying that Clara.io is intimately tied with Three.js. Not only is we support import and export for Three.js formats,
Mhm.
Clara.io is actually built with Three.js. All the way to the core. And to do that, we've contributed a lot to the Three.js source code base, a lot in the math libraries and a little bit in the scene management, but mostly in the math libraries. How about I start off by going over what is Clara.io and what we've done with
It's
Three.js.
good.
Let me show my screen here.
Excellent. I think you're gonna appear soon.
Okay, so what is Clara.io? Right now it's an abstract term, but let's see. Clara.io is a website. If you go to clara.io, you'll see what we've built. It's what we've tried to do is we've tried to build Google Docs for 3D. Basically, it's a powerful, full-featured 3D editor that runs in the web browser. It's very comparable to Blender, 3ds Max, Maya, and tools of that nature. So Cinema 4D, Modo, a little bit like SketchUp. Um, what exactly does that mean? It basically is this feature set. It's modeling, scene layout, materials and lighting, rendering. And when I say rendering, I don't just mean WebGL rendering. I mean photorealistic rendering using, say, an offline renderer. We in our case use V-Ray. Full import and export, not just of your models, but your animations, your materials, your lights. Um, it enables collaboration because it's online. Multiple people can edit the same scene. We also save every version that you've ever created. Uh, and we also allow for publishing. So using Three.js, you can publish your scene and embed it into web pages without having to write any code. You can also embed your scenes as V-Ray renders, so it automatically starts rendering in that iframe. I'm going to give you a quick demo of what I mean by these features in a moment. The other thing I can explain before getting into this is our history and how we got involved with Three.js. We first started this in 2010. We first came up with the idea, sort of seeing that WebGL was on the horizon. 2011 was a lot of planning. And in 2012, we began seriously coding the app. And while we didn't use Three.js at the beginning, within about 8 months of starting the project, we really were running into a lot of hassles using WebGL.
Mhm.
And basically, we were reinventing Three.js, but we weren't doing as good of a job. So it was sort of a no-brainer for us to move over to Three.js.
Excellent.
Um, and there really is nothing comparable to it. Um, we announced the product last year in the summer, and then we started our beta in the fall. Um, and this year we've added a library, so you can now find a lot of free 3D models,
Yeah.
and you can export them from our website into Three.js Live. We've added online rendering, and we are aiming for a potential release this year if all goes well. And we don't know what's going to happen next year. Uh, so let me show you what you can do with Three.js if you have a team of 10 people and you work for a couple years.
Let's go.
So here is what, when you start up Clear.io and you sign in, you're going to be presented with, this is your scene list. Normally, if you're a new user, it'll be empty. But I've been using the app for a while, so I've got a number of scenes here. Usually
Oh,
what you do is sorry, go ahead.
no,
Oh,
I was just acknowledging. Go ahead.
okay.
Great.
So usually what you do is you click New Scene, and then we've got a number of example scenes to pick from, or
Mhm.
you can create an empty one. Let's, since this is sort of an introduction, let's create an empty one, and let's start from the basics. This is the Clara.io UI. It is very similar to the existing desktop tools. Things may be just in a different spot than we're used to. So the first thing you notice is we've got 4 viewports. What the viewport is showing is described right here. This one is showing left. This one's showing top, front, and perspective. And you can change those very easily by just picking what you want here. You can maximize or minimize any viewport whenever you want, if you want to get a closer look at things. The next part is this creation toolbars here. We have polygons, light types, rendering, and other. Let's create a box just by clicking here, and it instantly creates it at the center of your viewport. And now you can see that this is a perspective mode, and when you move it here, you see it reflect in the other viewports instantly. This is very similar. The movement style is very similar to the Three.js editor, and much of the code is the same for that aspect of things.
Okay.
I should quickly note that you can switch between the different movement modes by hitting the W, E, and R key to go between translation, rotation, and scaling.
I remember that you have quite a bit of video on YouTube to explain the detail of how to use Clara.io. People
Yes.
can go there and learn more about all the keys and all, right?
Yes, yes. So, yeah, and then so let's see, what are the other aspects? The other aspects are basically, we have a scene graph on this side, and this contains your objects, your material libraries, your renders, and passes. On this side, we have what the object is, and we use something called a plug-based system, which is similar to Maya, in that each object has multiple different parameters. In this case, this one has a polymesh, it has a transform, it has properties, and then it has its material. And so what you can do with this...
Just a question, what is a polymesh compared to a mesh?
That's actually a key difference between Clara.io's internal representation and Three.js. When you want to render something, the video cards or GPUs actually only truly understand triangle meshes.
Yes.
And you want to have them as triangle meshes so in your game so that they render as fast as possible. But when you're creating content, you actually use something called a polymesh, which means that the number of vertices on each face is not limited to 3. It can be, often they're quads, that's generally how artists work, but you can have like 5 vertices or 10 vertices. And what we do is during export to Three.js, we triangulate those surfaces for you so that it's ready for your game. It's just easier to work with in the modeler if you don't have to work with that restriction of GPUs.
Okay.
The other,
That's going to be a cool answer. Go on.
Yeah, it does mean that modelers are by nature somewhat slower than game engines because they offer more flexibility. We also do, the polymesh representation that we use also has unlimited number of map channels. That means you can have as many UV sets as you want. We allow for color sets, normal sets, and we allow for something called index normals, which also games don't tend to use, but modelers use them.
Okay.
Let's see. We also
explaining the policy, the property of it.
Yes.
Go on.
Let's see, what else? The other key difference between Three.js and a modeler type tool is that they support operators. So I can take this box and I can start applying operations to it, such as I can add a mesh smooth, and then I can increase the number of subdivisions, and then I get a sphere. And then what I can do is I don't have to actually work on that mesh smooth there. I can turn that mesh smooth off and then go back to the box, and I can then start editing its points. So here I can just start moving things around. And then I can go back and I can put the mesh smooth on top, turn it back on, and now I've got a different position or a different orientation. Let me remove that, and I can show you, so the way that poly editing works, and you don't want to do this in the game engine, you do this in your modeler beforehand, is you basically pick the type of elements you want to work on. So I can work on a pure object, or I can work on its faces, and in this case I can select some faces and move them around. Or I can click on things like I can extrude that face, and that adds another face to that previous face, or I can bevel that face. We can also do things like we can cut our objects, and then that's cutting the face, and I'm leaving both sides, but I
Steve.
could, yeah. So that actually, yeah. So it is very generative, or you're trying to create new content here, whereas in a game you're trying to play it back as fast as possible, and you want to do this beforehand.
Okay.
Uh, yeah, and so we have most of the standard tools that you have in 3ds Max and Maya and Blender, and we have them both for faces, edges, vertices, and then we have this combined mode where you can go from a face to an edge, and it just depends on whichever one you click, and then it's going to be in that mode. So it's sort of an auto-switching mode.
Okay.
And I could spend some time showing you how to model something, but we do have a lot of videos for that to show you the details.
We will add a pointer in the synopsis of this course. We will add all the pointers that we are currently talking about.
Yes. So the other thing that this tool does is it does lighting. And a lot of so everything you're seeing here, all these viewports are Three.js. And so when you create lights, you're actually creating Three.js lights. So we've got the Three.js hemisphere, we have the directional. And what's cool is because we're using Three.js, you see it all live in the viewport right away, which is really, really nice to work with. So you can see that I can change my lighting on that specific object by changing my directional. The other thing that we can do is it's very easy to import and export objects. So say you've got some formats that Three.js doesn't support natively, or that you want to edit before bringing into Three.js. It's just a simple matter of dragging and dropping those into Clara, and then you can edit those and then re-export those. So here's a .blender file that I'm just going to drop.
Okay.
And then it first uploads, because one of the differences is ours is all online. So if you're going to do an import, it has to first upload it to our server. Then our server processes that, and then updates your Three.js.
All the texture, because when you drag and drop like that, well, I don't know the Blender file format, but you need obviously the vertices, all that. But for the texture, for all the texture, how do you drag drop the whole model like that? Is that possible?
Yeah, so let me see. I'm just going to find so this I imported the TIE Fighter, and that worked out.
A typical classic.
Yeah, so here is an OBJ file. I'll just create a new scene here. And if I wanted, this is a multi-part file. It's got an MTL, an OBJ, and the texture. And all I do is I drag and drop them all at once, and I'll upload all 3 files. And what I'll do is I'll import the JPEG first, then I'll import the OBJ, and then I'll import the MTL, and the MTL references the JPEG, and then it applies it correctly.
Excellent.
So, and it takes a few seconds for it to load back in. Oh, this is a moderately big file, so it's taking a few moments, but...
Yeah, no, that's cool. That's cool. You answered the question. We don't have to wait for the upload.
Yeah. Cool. Yeah, but we do support all... I'm having a bit of a browser issue here. Not really sure what's going on. Yeah, so yeah, we support lighting, textures. If you want to add your own textures, you can just import them in.
Cool. You seem to have some local issue.
I'm not really sure what's going on, but my browser is very unresponsive.
The demo usual effect. Don't worry,
yeah,
people are
but
aware.
If it doesn't work. So actually, it did import correctly. I can see that Buddha here.
Okay.
So
cool.
I'm not really sure what happened at the other browser. But that's one cool thing, is that even if your app crashes, we've actually already saved all your data.
Excellent.
And you can see here we've got a nice texture. And if I don't like the normals, which in this case, they're sort of, it's a bit faceted if you look at it. I can actually quickly edit that by going to Tools. I select my object, and in this case, I can go Auto Smooth. I click that, and then it gets rid of that faceted look. And then that's because it put an operator on it automatically. And if you wanted, we'd slice it again, there, and we've just removed half the object in that place. So it's very easy to start editing your objects this way, and everything is very quick. One of the other things that's neat about Clara and we focused on, is that you can have multiple people editing the file at the same time. And then you can start fighting over what changes you want, or you can just be more productive. And to do that, you just click share, and then you enter in someone's username.
That's
Yeah,
surprising. So artists gonna collaborate together over the internet, like live, something like
yeah,
you edit a part of the object and I edit the other part from the other side of the planet.
yeah. Well, what do you have an account on Claire.io?
Yeah, no, let's not do it now.
Okay, but it does. It
But
works
that's really
absolutely
cool. I
live.
like the
So I can show
possibility.
that actually. Let me just it works live just as well as it works if I create two browser windows. So you can collaborate. One of the problems with web browsers is some people like to have multi-screen apps.
Mm-hmm.
Um, but web browsers don't do that. But what you can do though is you can actually just load the scene twice, and in two web browsers.
Mm-hmm.
And then because it's collaborative, you can see here it's changing that.
It's live, man.
Yeah,
Excellent.
so
Excellent.
yeah, so
I
you can
wasn't
have
aware
one
of
that's
this
previewing your
possibility.
whole scene. You can have the other one just modifying stuff, and all your imports work live too. So like I can change the texture here,
Okay.
uh, and it's now this is not going to be a pretty texture because this texture is not appropriate for this object. But I just drag a JPEG in, and then I
Okay.
have to find the properties for the JPEG. Um, Giving that a sec. There we go. That imported. And then I can just change my texture here to the tiger texture, and now it looks ugly in both viewports.
So Tiger Buddha kind of stuff.
Yeah, so one of the things that happens with that collaboration is we do save all of your history. And so you can see every change you've made. It's like Git in that way, but it's
Mhm.
for your 3D scene. And that's actually how we do that collaboration. Every time you make a change, we send a diff to everyone else that's listening. Um,
Cool.
and
Are you actually using diff on Git or you did
we're
it yourself,
using
I guess?
diffs. No, we're not using Git
Good.
specifically. We're using a diff-based versioning system. Um,
Excellent. Cool.
The problem with Git is that we actually have to run in the web browser. So we'd have to have like nscripted running on Git in the web. It's actually simpler to do, and also Git requires you to download the whole repository.
Hmm.
We don't do that because we have to be as fast as possible. But you can go back and you can just undo your changes, and you can see that everything comes back, and you can play them back.
I directly see a very big usage is something like suppose I contract a modeler and I give him some advice of what I would like to have, and the guy is doing the modification live, and I can see live the modification. So the interaction between the modeler and let's say the guy willing to have to use the model will be very smooth. I like it.
Yeah. And I
Cool.
think it's great for people also creating Three.js games. Many of the people creating games these days are virtual teams. It's like five guys or three guys who are just good, but
Yeah,
they
yeah.
haven't even met each other in person. And now you can have the art guy, and it just works with everyone else. The other thing that works really well with that
Hmm.
is we've built a full REST API for Clara.io.
Okay.
Um, Actually, I should say one of the reasons why we've been able to add so many features to Clara.io is because 3JS provided us with great viewports and all the 3D calculation stuff, so we didn't have to focus on reinventing that. And that did let us focus on these additional features. So let me just. So one cool thing is if you're making a game, you can actually just write stuff to create to export a scene from the command line. So it's just as simple as doing a get on Claire.io API scenes, then the scene ID, and then the export,
Can you
and then
increase
the
the
file
font
extension.
there? Can you increase the font so people can see better? Excellent, thanks.
Yeah. So and 3GS is one of the supported file formats.
Hmm.
So you can actually make your web game actually live export from Claire.io when it runs, instead of actually saving your files to disk.
Okay.
Um, or it can export to Collada. My recommendations, though, when using Claire.io to create content for 3GS,
Yeah.
is I don't actually recommend using the 3GS file format. I recommend Collada. The Collada loader in 3GS is actually excellent,
Mhm.
and it's a more of a standard format. I'd
Yeah, but the
recommend.
performance for a game are not exactly good
Uh,
because this is a very big format, right? That's a very
Yeah.
big, as in, I have to download the whole things, and it's quite verbose. In
Um,
production, I mean.
yeah, well, it is, but 3GS format is also verbose, though. It's JSON as well.
Hmm?
Like, I mean, there's no pure binary format yet for 3GS. So I
Oh,
don't.
there is. There is.
Oh,
No, we
it's a
can
new.
talk to that, but there is one where all the vertices on all the face, all the float numbers are stored in a big binary file. And that's a big advantage when you load.
Oh,
Oh,
okay. So
those.
we actually do that when we load meshes in Claire IO.
Hmm.
Or we have an internal binary format. But what is the format that this 3GS format you're talking about? What's the name?
That's a JSON binary. So
Okay.
you got a very small JSON header, let's say, when
Yeah.
you say meta information, these kind of things. And after that, you got a big binary file. On this binary file, store all the usual float. So that
Okay.
means like all the vertices, all the face index, all the normals, whatever you need. The main advantage of this format is when you load it, you are creating a buffer geometry.
Oh,
This is a
nice.
very specific case for production game when you are waiting ready. In production game, you need to load fast. It's very important for the success of your game. But that's
Okay.
cool because your tools is not oriented with this. It is more development, right? So,
Right, but we should add that format to our exporters.
yes,
So that you
probably.
can load it directly. One thing we'd like to do is add caching. So if you export the same scene multiple times, it only exports it technically once for that
Okay,
version and just serves you the files.
cool.
But okay, we got to get to that format. I didn't know that existed. I
No,
learned
that's
something
cool.
new. It's
That's
great.
the main advantage of doing meetings, right?
Yeah.
Excellent.
Huh. Yeah, okay, we got to publicize that more. I actually didn't even see an example in the 3GS examples for that.
No, I'm gonna give you the link.
Okay,
Go on with
perfect.
your class, you man.
Okay, let's see. What else? The other thing that's very good for uh, collaborations is we have the ability to, you can make your, like with Google Docs, you can make your scene public. So by default right now scenes are private, but you can make them public and you can make them clonable and you can specify the license. So
Once
once
again,
you
for
do this,
collaboration, that's probably really good.
yeah, or and
Hmm.
what we're trying to do is we're trying to make a whole library of models that people can use in their games. Because a lot of people want to make cool games, but they don't want to spend a lot of time actually modeling.
Yeah,
And
I'm
so
just
if we
saying
can help
so.
that,
It's
so what?
probably very hard to. When you are a coder, you probably don't know how to model. I speak for myself here. Oh,
Yeah, and you saw my modeling. I wasn't doing very well either because I'm technically a coder.
okay.
So what happens is once you make the scene public, you actually get a view page for that,
Yeah.
and then your scene is available online. And we
Hmm.
have a library here that if I could look for this. Now, unfortunately, I didn't pick a good name. Let me change the name to maybe Tiger 3JS.
Okay.
Um, and because I made it public and I put it in the gallery, if I
Hmm.
type in 3JS here, we now can find that.
Mm.
And
Cool.
you can see it in using 3JS, and you can see it what the actual model is.
Hmm.
You can download that in your choice of format.
Okay.
Um, and you can get an embed link, and this means that you can use it as an iframe and then share it with your friends. And we have both WebGL, but you can
Mhm.
also pick a V-Ray embed.
I,
Um,
you got this with interesting feature of cloud rendering. Maybe you can tell us more about that.
okay, so that's now that one isn't as relevant to the 3GS community though,
Okay.
but it is relevant to people that use Maya, 3ds Max, and
Okay.
Blender because that's one of the use cases for it. So
Hmm.
let me bring up a scene that looks better than the ones I've been using.
Okay.
This is some Lego minifigs. That's the Lego characters
Okay.
um,
I,
in the style of Daft Punk. So here we set up a scene. We've set up gold materials on one of the characters, and I
okay.
guess this one's titanium. The way that we did that, we set up these nice materials, is that
Hmm.
we have a material browser. And this material browser, though, is of high quality materials intended for rendering. They're not all supported in 3GS because they're actually they're very computationally intense.
Okay.
We do have hundreds and hundreds of materials available here. Um, and once you set those up, you can of course render it in 3GS, But you can also render that using one of the best renders in the world. It's called V-Ray. And to render, you just click Live Render and you go Fast Preview. And then it automatically starts up a machine on the cloud. It loads up the scene, and then it starts rendering and sending you the images as they render. And there we go. So now that's actually doing very complex light calculations. And just like collaborative editing, I can interact with the scene, and it updates in real time.
That's funny, man. Excellent.
And I can start changing the materials to, well, let's pick, let's say I wanted him to have this weird blue car paint. Oh, I got a crash there. Huh. I was about to happen. But let me just restart that render.
Yes.
And that should work. So the other aspect with that embedding, I was saying you can, it turns out that maybe that material is not properly supported in V-Ray Live. I think that's what's happened. You can take these files and you can embed them in web pages. So here is an example of JS Fiddle.
Okay.
And I just put an embed saying this is an embed and use V-Ray. And you can put this in your web pages. If you're a 3D artist who wanted to show off what they're capable of, you can now put renders in your web pages that people can interact with. Sort of like a YouTube video or a Three.js embed. So that's the publishing aspect of Clair.io. We're just trying to make it easy.
There's a picture every time I reload my page?
Yeah, and we can handle, I think the most that we've done in one day so far has been 13,000 render embeds in a single day. So we have a render farm set up to handle that load.
Okay, excellent.
Yeah, and actually, funny thing is, it's actually running Three.js in the background to manage the scene. And then we've got translators that translate that to V-Ray. So even in this case, you don't need WebGL. It works great on tablets, but it's still using Three.js.
Okay.
So, Three.js everywhere.
Exactly.
That's sort of our rule. Yeah, so that's a lot of it. I guess I can show you, we've got some Three.js. If I come back to, had some browser crashes, but
that's cool, man.
Yeah, so let's see. We can actually transfer our scenes very easily over to the Three.js editor as well. So if I still recommend Collada for transmitting the scenes because it is the most feature-rich format.
Okay.
Because I find that not every feature gets stored in most of the formats. So it's FBX and Collada that seem to capture your lights, your cameras, your textures.
Do you do animations?
We do animations. Yeah, okay, I'll show you that next.
Okay.
So if I was to come back to the Three.js editor here, and I've got that Collada file that I've exported. I'm not sure where I saved it. Okay, so it's here.
Take your time.
Just a sec.
So we are trying to find the format.
There we go. And then I just drag and drop it in here. And then we have the same scene. Okay. Now, I do notice a few differences. One is we're using V-Ray specific materials. And that means that they can't be represented in Three.js. So that's why they're coming in black. If you want them to be represented in Three.js, you do have to use. So in Clair.io, we do list things that are Three.js specific and things that are not. So in this case, if I click on this guy and I go to his material, you can see that it's V-Ray / Vismat. So that's a V-Ray only material. But if I wanted to, I could take this guy and I can add a standard material, and that's just called here new material, and then this one actually works in Three.js. Cool. So things that are general that don't have the term V-Ray in them work in Three.js. The things with V-Ray in them only work in V-Ray, and that's because
Three.js, unmodified Three.js, the one that I can get from Mr. Doob repo.
Yes.
Yeah. Cool.
Yeah. So we actually, this is almost exactly the Three.js format right here.
Okay.
All the way down to the cube map. and you can even pick Fong or Lambert. And then we also support, and it's compatible with Three.js, is we do support multi-material IDs. So you can put one material on an object and then reference the sub-materials in them. So each face can have a material ID.
Cool.
Yeah, and the other thing when I came here is I noticed that some of these meshes, you can see through them.
Yeah.
The reason for that one is it's just you're using double-sided within Claire.io on some of these.
Okay.
And there, so as soon as I fix the double-sidedness, then we don't see through it anymore.
Okay.
So yeah, so okay, so we can go back to animation then. And if I wanted to do animation, it's pretty simple.
Okay.
I'll start with, I guess, a programmer scene. I'll make a plane.
Mm-hmm.
I'll switch to shaded, and I'll put a box on top. And if I wanted to animate, it's actually very similar to other tools. Let me animate the position. And so I go to the transform plug, and I can set a keyframe. And I'm just going to, and the way I did that is I right-clicked on what I wanted to set as the key.
Okay.
And in this case, I clicked on transform, and it sets a key on X, Y, and Z. I can then move to somewhere in the future, say frame 60. I can move that to a new location. And when it goes orange, that means that it's moved away from what you've saved. And it means basically if you move again, it's actually you're going to lose that change. Green means it's interpolated, and orange means you haven't saved it. So you move to something, becomes orange, you set a key, and now it's red. And so now when I move between these two keys, it moves. So it's very simple, but that's generally how animations work. You just have to build up a lot more on that. So we can almost anything in Claire.io is animatable. So one of the things that people like to do is you can change your depth segments. And so here it's going to be 10. And so now, orange, so I have to go set key so it becomes red. And now you can see when I move, it animates the geometry of that mesh.
Okay.
And you can animate basically anything. You can animate operators, so if we wanted to, say, twist it, we can then set it, we can go at 60, we can set that, and then we can go back to here, and we can go 0 twist. And then we can set that. There we go. Now when we play, it's twisting and it's setting more faces. So now these do export correctly to Collada and FBX. But they do not export into the current Three.js file formats because they don't actually support keyframe animations, general keyframe animations. They not at least I think that they support bones and skinning, but they don't support keyframe animations on most parameters.
Okay. Yeah.
Like if you animate a color, say on a diffuse material, which you can do in Claire.io, that won't be represented in Three.js.
Okay.
Generally, because that's not done in games, so I understand that limitation. So I guess the other aspect we can show, which is supported by Three.js, is skinning and animation, skinning in bone systems. So we've sort of got this classic Bumblebee transformer here that we've set up a simple skinning animation on. And you can see here we've got a set of bones.
Okay.
And this is just going down his arm that we've added keyframes on. When you click on an object, you'll see its keyframes will show up in the timeline as marks. So these are the keyframes for this bone. And then we have our Bumblebee mesh here, and on that we've put a skin. If you've done skinning in Three.js Max, this is very similar to that. You create a skin, you assign your bones to that skin, and then you have your weights that are also calculated. And then when you press play, you can move those bones, and then the character follows along.
All right.
And if I go to a single viewport here, there we go. And you can see that it plays at 30 frames a second, which is what we set as our playback speed. We can see if we can go any faster by coming to our timeline and saying that we actually want it to play at something faster. And we'll probably run into the limitations of Claire at some point.
He's doing
there we go.
He's saying hi or something.
Yeah, so that's actually pretty impressive.
Robot. Okay.
That's Three.js running at 60 frames a second in the web browser, skinning characters, and our skinning is CPU based. That's actually a major difference between us and a game. all 3ds Max Maya, they always do skinning CPU based, and they allow for unlimited number of influences on each vertex. It's only when you want to export to a game that you optimize it so there's only 4 influences or whatever per vertex, because then you can do it on the GPU.
Mm-hmm.
But you design it usually without any restrictions. So that's sort of a common difference. Clair.io usually picks the unrestricted way of doing things that's
Mm-hmm.
slower.
Okay.
And that we trust that the game engine will do the fast way that's more restricted. But that's
Sure.
why there is different tools for different tasks.
Exactly. Perfect.
Another thing
I like the
that
robot saying hi all the time. So,
yeah, and we can modify that easily, but I won't do that. The other thing that's can be useful if you're used to 3ds Max or Maya, one thing that people do is they constantly write plugins and scripting.
okay.
So we support that as well.
Mhm.
Now this we do deviate from 3GS in this fashion in that we don't 3GS is not our scripting language. But every time you make an edit, it does echo to our log the scripting command that was equivalent to what you just made as an edit. And what you
So
can
the
do,
log is all the text that we see. Can you zoom that a little bit? If you can,
yeah,
it will be. I don't know. Probably gonna zoom the whole interface. Okay.
there we
So
go.
the log is there, and you got all the command. Okay.
Yeah, and
Come back to the usual scale, or we don't see the upper part.
oh,
That's what just to try.
just give me okay. Let me go down. So what's
Mm-hmm.
cool is you can, if you read what's here,
Mm-hmm.
and you want to script that, you can switch over to the scripting window, and you can just cut and paste.
Okay.
And then let me just go read it. I'm going to grab the name of this. So this is from the previous scene. I actually applied a twist operator.
Okay.
In this one, I can say on Bumblebee, apply the twist operator here, and I can press play, and then it executes that script and puts it there. So we have the full scripting capabilities that you expect in 3ds Max or Maya.
Mm-hmm.
In that you can basically anything you can do through UI, you can script. And you can write your own operators as well. We have an SDK for that. Or if you want to do things simply,
Mm-hmm.
script. You can add a script operator. Ooh, and this one had an example script in it. But you can write your own JavaScript that'll apply
Okay.
within the context of Clair.io. And it will apply that to the mesh every time it's displaying it. You can do that both for transforms as well as for polymeshes.
Good
So you can
flexibility.
customize it there. You can add arbitrary metadata to objects, which can be helpful.
Okay.
The other cool thing with coming with the scripting is you can actually do your embeds, and you can actually use that same scripting language to modify your embeds. So in this case, this is a Clair.io scene up here.
Yeah.
And what we've done is you can add jQuery, and you can run scripting commands within Clair.io. So anything that you can, so if you can customize it within Clair.io, you can then use that same echoed script to then write interactive experiences.
Okay.
And it can, now this doesn't provide, this is never going to be a game engine. This is more for maybe viewing a product or configuring a product. I would never write a game engine this way because Clair.io is fundamentally slower than a game engine. And like you shouldn't, and it's also not meant for that high performance type deals.
No,
But
but it has a lot of usage. But I guess people doing games can devote the time to display that faster.
yeah,
So
like this code here, there's almost nothing to it. So I can show you the code.
you're gonna have to increase the font, man. We don't see much. Can you increase?
So
Yes.
yeah, so
Perfect.
in this case,
Mm-hmm.
all it did is when someone clicked on the button, it
Yeah.
then just used that exact script that I was using uh, in the script window there, and it just applies it. So in this case, it just moved the camera. So you don't even have to actually understand very much about how to actually script. You just have to be able to cut and paste basically from the script log
I see.
what you want to do.
Mm-hmm.
So it's very low barrier to entry for doing things.
Excellent. Yeah, because people can interact with their scene on Clario. After that, they pick the command that they like, and they just could paste that in the application.
Yes, and it's running Three.js underneath, so it's just a simplified language on top.
Okay. So,
Yeah. So I'm not sure what else is interesting. Like I can of course go into more details of modeling in that, but I'm just not sure if that's where you want to go.
I don't know, man. That's your talk. You pick. I like the deformation.
Yeah, I applied a twist on top of him waving. It's sort of weird,
Yeah,
but that
the
is one of the
weirdest
things that you can
robot I
do.
have ever seen, man.
But that's one of the features of Claire.io is you can basically combine whatever you want. Now, most combinations are ugly, I'll be honest, so you have to have some skill to figure out the right combination to achieve the look you want. But
Excellent.
um,
So
yeah.
I don't know. Maybe you can pick the slide that you had at the beginning to show all the features, and you pick one that you find best, and
Um,
take the slide that you have at the beginning. Yeah, I remember you had various topics that you wanted to talk about.
uh, I actually think we've talked about all of them. Um, I can go into
That
more
was
details,
very
but
efficient. That's cool.
um, let's see. I can't talk about where we're planning to go in the future. One
Hmm.
is I've got to start implementing that binary Three.js format you just told me about. I'm actually somewhat embarrassed that we don't have it in there yet.
Hmm.
Um, we're going to be adding a UV editor, and a UV editor is very good for applying textures and cleaning up your textures,
Hmm.
uh, and um, and making the UI easier to use and making it more scalable. Uh,
The UI
so
has to be scalable.
sorry.
Mm, sorry, I'm just asking a question here. I don't understand what you mean by the UI has to be scalable. The UI
Oh,
is running inside my browser. Oh, you mean being able to process more complex model, maybe?
yes. So right now, we find that Clear.io can get slow if you have 500,000 vertices,
Well,
and we'd like
quite a
to
bit already.
quite a bit. But people on the desktop are used to running millions of vertices.
Yeah, yeah.
Uh,
Yeah, but when you are, at least in my case, when I'm doing game on the web, you see, you cannot do million of vertices because if you do that, you will have a download time which is going to be slow. You can, above 200K vertices is way too slow to download.
oh, really? Okay, so that's where you're finding the limit. Okay.
Yeah, yeah, yeah. After that, you have something like 2 minutes download or things like that. And just people don't play your games because they have to wait 2 minutes to load it. So on the web,
Ah,
so they don't do it. But that's the
okay.
game part of it, right? You don't have
Right.
to be only Karayu is not only for game. It can be used for game, but it's not only for game. So for this one, I guess.
Yeah, okay. So one of the issues that we have is that
Mhm.
people that want to render in V-Ray,
Okay.
um, often we've had people trying to load up like 5 million point scenes, and then they're like, "Hey, wait, it's
Crash
not
test,
working
test,
that well."
test.
So we do have to support that. One of
Mhm.
the things that we've been doing to that is we've created an idea of proxy objects. Now,
Okay.
this is not relevant to making a Three.js game,
Hmm.
but what you can do, this is going to load up. This is a heavy scene.
Let's go.
There. So this one has 200,000 polygons and 100,000 vertices. It's a
Okay.
nice sculpture here of a dragon.
Okay.
Um, but if you wanted a lot of these, it's actually really slow. If I wanted to load up 10 of these or 10 equivalent things, instancing, of course, you could do it. But if you weren't instancing, um, how would you do it? Well, what we've done is we've got this ability to go to a proxy object. And what a proxy object is it takes the current representation and replaces it with a cube in your viewport, but
Okay.
it leaves the high resolution representation when you render using V-Ray.
Excellent.
And so I can start live rendering this. Hopefully it loads up because it is a big mesh.
Okay.
And then let's see if this gets up. Um,
Stressing time.
yeah, well, just the last day or so live rendering, we're doing some improvements and it reduced its stability.
Well,
So
yeah,
it's
yeah, yeah. No, we perfectly understand that a demo and you are doing that on the very last version. So that's completely
yeah.
cool.
So I'm just going to clone this object around. I can start moving these cubes,
Okay.
and these are actually the dragon.
Also,
underneath.
you can still edit even if it's uploading already. Excellent.
Actually, yeah, that's one thing that we have that Claire.io, we actually queue all your changes, so
Mm-hmm.
you can actually make changes almost as fast as you want, and it'll catch up. So you can always see what's going on. In the bottom left corner, there's a checkbox.
Okay.
If a checkbox is there, it means all your changes are saving. But if you're moving things around a lot, you'll see that it becomes a circle, and that means the changes are currently pending.
Okay.
And it does look like the scene is not actually going to load, unfortunately, today. But yes,
Hmm?
unfortunately, it's not. I'm not sure what's going on here. But normally it would, and you'd see all of those objects. And then you could actually have 20 of these objects, each having 200,000 vertices, and they would render correctly, but it wouldn't overwhelm your browser.
Cool. I understand the problem now.
Yeah. Oh, there we go.
Here we go.
So there, I've just got 4 of them. So that's 400. Sorry, 200,000 times 4, so that's 800,000. And I can select all 4 of these.
Okay.
I can go clone, and I'm going to copy them, and I'm going to move them over here.
So it's going to be 800. No, 800. 16.
There we go.
1,600,000.
Yeah, so now we've got 8 of them, and it's
Okay.
actually pretty interactive. So
Mhm.
because we're doing all the hard work on very powerful servers on the cloud, yeah, so that's basically one way that we're scaling. We've just got to get it to start up faster, because that was a bit slow in my opinion.
Yeah.
And of course, I can take this and I can apply a cool material. So maybe I can make them. What's a nice material here? Well, that's pretty.
I don't know. Pick one. Some funky texture.
Yeah, there's no texture chords on this object, so I've got to pick
Yeah.
something reasonable. This silicone rubber seems interesting if it works.
Sorry, I have a silly question. What is your object at your display when you are doing the material picking? You have a weird object with like I don't even know how to do it.
Oh, it's this object that we're showing here. It's actually just a material test object. It's very.
Okay.
If you look at there's material test objects for Blender and V-Ray, and they usually try and have curves and sharp edges and contrast with existing shapes. So that's why we have this, because you can see if we had a perfect sphere, you wouldn't see how it reacts in sort of a tight crease there, or how it works besides a white object. Or if you have a glass or semi-transparent. So this one you can see semi-transparent. You can see the white underneath it.
Okay.
And the distortions. So it's supposed to just be an interesting object.
Okay. Cool.
And so here now we can I can take this view here and I can zoom into my object, and then this won't catch up. There we go. And then you can see that I've got a pretty nice clear object that's distorting its background.
Okay. Excellent.
Yeah, so that's basically our scalable rendering. But we're trying to, what we're looking to do in the next couple weeks is have it so that we'll send a reduced representation. So even if people are finding that bounding boxes aren't actually that great. They would prefer something that sort of looks like the dragon but doesn't have all the vertices. So maybe it has 10,000 vertices and it's sort of rounded out. And that would be better. So you can sort of see what your scene looks like in the viewport rather than cubes. So we're looking to do that. We're also looking to get, one problem that we've had is we've had people who are used to rendering, they're uploading 10,000 by 8,000 pixel textures. Now that's great.
Because I know the technical problem behind it.
So that's great for rendering, and we can put that into V-Ray, but that doesn't make sense for any real-time viewport stuff.
Yeah.
So we're looking to add automatically reduce the textures for the viewport so that it can possibly load. Because I think that texture there, I think it was actually 70 megs for one single texture. Now, it was a beautiful texture.
Okay.
So we're looking to make it more robust in the presence of massive data sets.
Okay.
And I think that's actually really important for usability, because then people can still load these scenes fast. They're just working on a proxy representation of what actually is there.
Indeed, yeah. And I have to ask is, what is your target with Claire.io? Do you target something like a beginner modeler who want to learn more easily how to do something with Clara.io compared to Blender, Maya, or you try to be on par with Blender, Max, all the typical modeler? What is your target?
We would, well, Maya and Blender are both, I think, around 15 years old.
Okay.
Um, actually, maybe more like 20. It's unrealistic for us in version, we're not even released, to aim to be on par right away. So we're necessarily starting at a sort of a lower set of features, but a lower set of features that's still pretty core to what people do every day.
Yeah.
And then we're looking to evolve from there. We're not.
Okay.
We're focusing on sort of ease of use. Very low cost. So our stuff is free, and for the V-Ray rendering, since we use expensive machines in the cloud, we will have to charge for that.
Okay.
But and a focus on collaboration, where all your scenes are available wherever you are on whatever device you want, and you can have everyone working on those scenes without having to share around Dropbox or other forums. And it's always up to date, and everything's configuration free. Because a lot of if you use Maya, you have to buy like V-Ray separately, and then you have to set that up and install it. And then Maya is constantly releasing a new version every, I don't know, 3 months, and then you have to install those. Whereas Clara.io is just always up to date. So it's low cost and convenience, and ever increasing power. Given that version 1 already has all of this, I'm really looking forward to how we go in the next couple years. And a lot of that is in part because of the great community around Three.js. So one feature that we have, I can quickly show, and this is directly from Three.js developer, is that we have booleans. So I can create a sphere, or sorry, a cylinder, and then I can make a cube, and I can move that cube up, and I can say, actually, let's do it this way. I can say from that cube, I would like to subtract the cylinder. And then I have. And so that was pretty easy to do. And we didn't actually have to code that. We found a great library. It's called 3CG.
3G, the constructed solid geometry.js.
Yes, and what we did is we just, since we're already using Three.js, integrating it was not that much work, and then I just tweeted to the guy and said, thank you, and like, you got to check out your stuff in here.
That's a great part of being a community. We can collaborate. Oh, that's cool.
It's amazing, and within Clara.io, then you can just do things like move around one object, and it constantly computes.
You do that right. Excellent.
Yeah, so that's being part of the Three.js community is just phenomenal. Like, and there's, I don't know, I'd say there's a useful tool being released like every week in the Three.js community. It's pretty amazing.
Excellent. So. Seems nice. Do you have anything else to show us?
Oh, I'm sure there is, but I'm not. A lot of it is just mesh tools that I think do appeal to, like, I'm trying not to do this for the advanced artist, but we have been working pretty hard to meet the needs of advanced artists. So we have things like Weld, Connect, we have edge loops, that you can select edge loops, you can select edge rings, you can fill borders, you can do symmetry-based modeling. That's very important for characters or heads, where you can have your edits immediately represented on the other side. You can do... one thing that I showed is that I showed doing, let me make a new scene here. One thing I showed is I showed making a mesh smooth operator. But generally people don't work that way. What they do is when they do modeling, they actually put mesh smooth on, but sort of in a virtual fashion. And we support that. All you do is you hit the plus key, and I can put on mesh smooth, but it's technically sort of a box at the same time. So I can go to here, and I can select the face of the box, and you'll see that actually I'm moving the box around, and it's showing you the resulting sub D underneath. So it's a little confusing, but it's basically you can model your low res, and it's showing you what the high res would be at the same time. Yeah,
congratulations on the work. I mean, I see all the work which is needed to reach this point of simplicity, let's say. Well,
yeah, and it's very powerful. It's very similar to what's in existing tools. So I can then select like an edge loop here, I can start scaling that outwards. Yeah, and so right away I'm creating, I guess maybe this is a chair.
Maybe something like that.
Yeah, I'm a
Okay.
programmer, so I tend to make very ugly things.
Yeah,
I think
I
it's
guess
called
I
programmer art.
understand.
Um, but yeah, there's a lot of features here in terms of the poly editing, and we're looking to add a lot more solid modeling tools,
Mm-hmm.
possibly sculpting. Although that's probably more than 6 months away. We just had a lot of requests for it.
Mm-hmm.
But basically, any features you want, tell us. We'll add them to the list.
That's very nice. I mean, I guess the community will be really happy to hear about that. Um, I think that's wrap up. Well, except if you have anything to add, I think that's a very good presentation about Clara.io on how it can be useful to the Three.js community. And
And
uh,
how it was 3GS was immensely useful to us.
oh yeah, that's the
Everything is
main advantage
3GS.
of open source is people collaborate and build on each other's stuff. That's why I love it so much. Personal comment.
Yeah, no, I agree.
It's excellent. Okay, so so let's wrap it up. Do you have anything to add for now?
No. Well,
Oh,
thanks for this, Jerome.
yeah, my pleasure. So it was a presentation of Clara.io by Houston, and he presented to us what can be done with Clara.io and how it can be done. There is a lot of tutorial available online. We're gonna link that when with the synopsis with the video. Thus, we can follow everything. Thanks, Ben, for your intervention. Talk.
Okay.
Sorry, that's the first one, and we are really happy to do it with you. Okay.
Thank you so much. And it was
Yeah.
great, and I hope we can be more useful to the 3GS community.
Oh, you have been very useful, and I love the work that you have done.
Cool.
Okay.
Okay. Okay, take care.
Bye.
Bye.